Okay, how many of you tried? Maybe you should definitely try it out. Alright, so let's move ahead. Let's take another grammar. In this case, the grammar is with respect to L values and R values. L values are typically the ones which appear on the left hand side of an assignment statement. R values are essentially values which we talk about. L values also signify R values. So our starting symbol is S, which is about which could be L equal to R, which is an assignment statement, or it could just be an expression like A plus B. In this case, that is not the case, but it could just be dereferencing of a pointer or some variable name like that. L value is possible to be either a dereferenced R value or it is an ID. So that is what the way we are defining the L value. And the R value could be any of the L values. It's because whenever we are talking about L value, that also gives R value. So we are not talking about constants at this stage. Let's say this is our grammar, right, for some reason. I would like you to derive this first and follow corresponding to this grammar, augment the grammar, let's say with S prime deriving S, complete the item sets, compute the finite automaton, and then compute the parsing tool. So please tell me what are the first and follow of S, L, and R. I know it is early morning, maybe midnight for some of you, but still, any suggestions on what could be the first? Let's start with first of L. What will be first of L? ID and star. First of S is ID and star. Okay. L is ID and star. Okay. And first of R should also be the same. Right. And there is nothing nullable. See, essentially there are three terminals in this grammar: equal to, star, and ID. Like equal to cannot be the first of S. It is also not first of L or R, and star and ID are the first of L, and first of L should be also first of S because of the first production. Similarly, first of R should also be the first of S, but the first of R is first of L, and therefore all of these boil down to the same star and equal, star and ID, and therefore that becomes our first. What is follow of S? That should be easy. Is same as follow of R. Good. Therefore, dollar. Okay, I think there is something more to it. Equal to dollar and equal to star ID. How would star and ID appear in the follow of S? Yeah, that I'm not able to see. Follow of L is equal to that is not complete. So that part is correct. Follow of L is equal to that part is correct. But there is something more to it. S dollar equal to L equal to R equal to dollar. Okay. So if R has equal to dollar, L should also have equal to dollar. Because R derives L. Therefore, follow of R, whatever it is, equal to dollar in this case, that should also appear in the follow of R. Right? And therefore, follow of L should also be equal to dollar. As far as follow of S is concerned, it should contain equal to and dollar. So all of these will have equal to dollar as the follow set. Star and ID will not appear in the follow set of S because there is no production which I see which contains star following what appears on S. Right? Anybody has any concerns on that? So we got little different answers, but if there is confusion we can discuss. So does that seem reasonable that follow of S, L, R, all of these should contain equal to and dollar? The reason being that follow of S definitely contains dollar, but follow of S will also contain follow of R, which is also follow of L. And therefore all of these are essentially going to merge in some sense. So follow of L is equal to and follow of R, right? Because L can be replaced by star R, therefore follow of R can contain equal to. And dollar is anyway going to appear because follow of R and follow of S according to this production is going to be followed by dollar. And therefore L could also be followed by dollar because of this connection. Right? Any questions on this? So please practice a little bit about this. Alright, so now that we have first and follow, can we now construct the first item set, I0. Well, that won't be difficult, despite deriving .s, and .s derives all these 5 productions. Right? I mean, .s derives .l equal to r dot r, and then L derives .star r dot id, and r derives .l. Right? So all of these come into picture. So that part is okay. Can you build the rest of the automaton? I'll give you a few minutes. I'm just typing down the item set that I think is going to be I0. So S prime deriving .s, where S prime is the new symbol. S deriving .l equal to R, S deriving .r, L deriving .star R, and L deriving .id, and R deriving .l. So that should be our great. From here, we should have transitions on definitely capital S. We will have transitions on capital L, capital R, as well as on star and ID. So please do that. And of course, the numbering convention will change. What is I1, what is I2, etc. Doesn't matter. Let's count the number of states you get into. You can mark some states, so whatever is the transition on capital S, whatever the state is, let's say I1 or something, it will be S prime deriving S dot, and from there on dollar, that there is going to be an accept state. On I0 on capital L, there will be S prime deriving L dot equal to R, because you would have consumed L. S deriving, did I say S prime? Okay, so it should be S. So the first one, I1, is S prime deriving S dot. On dollar from that state, there should be an accept. Then S deriving dot L equal to R should have a transition on, that I0 should have a transition which is on L, which goes to S deriving L dot equal to R. If I have said S prime, sorry about that. There is also another transition on L from I0, and that is R deriving L dot. Yes, that is correct. So there should be two such kernel items into that state. From these kernel items, there is any new non-kernel item that is getting added, so that forms another state. Okay. On capital R from I0, there will be S deriving R dot, and that does not add any more non-kernel items. Similarly, for shift, there will be on star, there will be L deriving star dot R. That will be a kernel item, and then R deriving dot L will be a non-kernel item. And since it is R deriving dot L, more forms are going to come, L deriving dot star R and L deriving dot ID. So it will also come into picture into that, into those non-kernel items. Another transition which will be on ID from I0 is L deriving ID dot, and that doesn't add any more non-kernel items. Right, so I suppose some of you have obtained this. So yeah, essentially that I0 is what we were considering, and then there are other transitions which are possible. I'm going to leave it to you to check if this, whatever I have obtained, is correct, and what are the transitions across these states. But essentially I got this 5 plus 5, 10 states. Okay. So there is something interesting in this in these item sets. Which state is most interesting to you? Anyone? Which state is the most interesting for you here? Is going to note down follow of SLR is equal to $. So that's what we have. Okay. For me, the state I2 seems to be very interesting. Can somebody tell me the reason? Right. So there is a shift reduce conflict coming into picture here. And why is there a shift reduce conflict? Right. Since follow of R contains equal to, and so therefore R deriving L dot is the reduction that you might want to apply when you see equal to. Alternatively, the first rule says that if there is equal to, then you should shift so that I can derive L equal to R. Right. So therefore, this particular grammar has ambiguity in terms of shift reduce conflict, and that does mean that when you try to create a predictive this SLR1 parsing table, you should be able to get some, in this case, this is going to go to L equal to dot R, that is where L equal to dot R, that is I6. So there will be S6 as well as there will be R, that is reduce 1, 2, 3, 4, 5, R5. So S6 and R5 should appear in the same entry in this predictive parsing table. So in case that happens, then that is going to be a shift reduce conflict. Right. So just to recap on that, due to the first item, the action of 2, $2 is the I2 state on equal 2, equal to, that is shift 6, and due to the second item, and because follow up, this part is important, don't forget that. In case follow of R did not contain equal to, then there is no shift reduce conflict. Because just by looking at the equal to, the lookahead sign, lookahead symbol, you'll be able to make a decision whether to reduce or to shift. Right? So only because it has a prefix of this, the same, L dot in I2 case, that doesn't mean that there is shift reduce conflict. Okay, so action of 2 equal to is going to be reduce R deriving L dot, and therefore there is a shift reduce conflict. Does that mean the grammar is ambiguous? Why is that? Okay, this particular grammar is not ambiguous, but why is that? So there are two aspects. One is whether the language generated by the grammar is ambiguous or not. We said that the language is ambiguous if there exists no unambiguous grammar corresponding to this language. Right? The particular grammar that you come up with for a particular language, that could be ambiguous, but there might be another unambiguous grammar. Right? So in this case, it so happens that not necessarily, in this case, I don't know if I meant grammar here or language here. But anyway, as far as our SLR1 grammar is concerned, that is definitely ambiguous because the parsing table that we have constructed that has those entries. However, with a larger, so SLR, for example, 2 or SLR3, that might turn out to be unambiguous in this case. But SLR1 grammar is definitely ambiguous. I think I meant language here. Does this mean that the language is ambiguous? No. Not necessarily ambiguous. Right? So in this case, it turns out that the language that is generated by this is not ambiguous. We might be able to come up with a different grammar to support it. All right. So let's move ahead. So we looked at how that SLR1 parsing table is built. Let's understand some portion of the viable prefix which we are actually reducing on top of the stack. Right? So the question is, why can LR0 automaton be used to make these shift reduce decisions? And that happens because the string of grammar symbols that appear on the stack, right, those are characterized by the LR0 automaton. So when we looked at LR0 automaton, we didn't really think in terms of stack. But that was something which got characterized, or you can say that I can have an abstraction of a stack, and if I will be able to show one-to-one correspondence between this LR0 automaton and this shift reduce on the stack. Okay. So the stack contains, the expectation is that the stack contains must be a prefix of the right sentential form. So the right sentential forms and the left sentential forms we looked at. The right sentential forms are the ones that we use in the context of LR parsing. So at any stage, if these right sentential forms are getting built onto the stack, that means the prefix of this right sentential form is going to appear on top of the stack. Okay. Interestingly, not all prefixes are valid. Initiations, why? I'll show you an example of why everything is not valid. So not all valid, not all the prefixes are going to be valid because only a few of them are going to appear as handles. I mean, because as soon as something appears as a handle, that needs to be reduced. You cannot apply a shift there, right? And therefore not all the prefixes are going to be valid. So as an example, if stack holds beta number of, the sequence of symbols is beta and the rest of the input is x, then the sequence of reductions that are going to follow after this stage should take beta followed by x to the capital S, that is the starting symbol. If in case this happens, then that string beta x belongs to the right. Well, beta meaning whatever is derivable from beta. So S in 0 or more steps should derive beta x is what we say. Right? So I'll just show you an example. So E deriving F into ID, and then from there we deriving a parenthesized expression into ID. Right? So these are all valid, let's say, handles onto the stack, or these are all valid sentential forms which appear onto the stack. And at different times in the parsing, the stack might hold opening parenthesis, then opening parenthesis and E, then opening parenthesis and E followed by right hand side parenthesis, but it will never hold opening parenthesis E, closing parenthesis followed by star, and the reason is onto the stack. What is the reason? So what I'm trying to say is that this particular string that we have, or sentential form that we have, not string, sentential form, this belongs to this language, right? That is given. And as far as all of these are concerned, this part is a prefix, this part is a prefix, and so is this part. Parenthesized E followed by star, that is what I am writing. This is also a prefix, but this is not a valid prefix, or in some sense this is not a viable prefix. This is not operable prefix. Why is that the case? Okay. Let me put it this way. On top of the stack, do you ever have parenthesized E followed by star? That is, there are 4 symbols on the stack. Opening parenthesis, E, closing parenthesis, and star. Okay. This, where is this going to appear on top of the stack? Okay. This is never going to appear on top of the stack. The reason being that as soon as you see opening parenthesis E, closing parenthesis, and the look ahead is star, you have to replace this opening parenthesis E, closing parenthesis with F. Right? Because we said that F deriving ID or parenthesized expression is a production, and follow of F contains star, and therefore as soon as this appears on top of the stack, you need to reduce it to that. Okay, so that's what I am going to mention here, and therefore parenthesized E is going to be replaced with F before we start shifting star, and therefore such an expression will never appear on top of the stack. So although it is a prefix of the sentential form, as we can see from here, it is not a viable prefix. So because all the prefixes of right sentential forms need not appear on the stack, right, at any point in time. Only the viable prefixes appear, and that is decided by when you apply the reductions. Right? So these are called as viable prefixes, and it has been shown that viable prefixes are the ones which are going to be recognized or which are going to get followed in LR0 automaton, and therefore LR0 automaton is kind of equivalent to this shift reduce parsing with stack. So SLR parsing is based on the fact that LR0 automaton recognizes these viable prefixes. Right? Just to kind of put it formally, if A deriving beta1 dot beta2, this is the context in which you appear right now, where you have seen beta1 and you are yet to see beta2. It is valid for this item is valid for a viable prefix alpha followed by beta1. If there is a derivation from the starting symbol which says that alpha followed by A followed by W derives in one step. So A essentially derives beta1, beta2, and from S you can derive alpha to W. I mean, this might look obvious, but because of reductions this might not be the case, right? So you might have some reduction for alpha beta1, and that will give a different viable prefix. So this is viable prefix alpha beta1 is going to appear only when such a A is deriving beta1, beta2, and you have seen part of it, and alpha appears as the initial part of this hosting and W appears as the next part of this hosting. That means that when alpha beta1 is on the parsing stack, it means that that means that we have not shifted the handle, and therefore we should shift rather than reduce. That means that we should shift beta2 rather than reducing alpha beta1, right, to A. And this is under the assumption that beta2 does not is not nullable. Otherwise beta2 will be nullable, and therefore otherwise beta2 will be nullable, and then you are forced to have a viable prefix in terms of alpha beta1. So this part, if beta 2 is nullable, then alpha beta 1 might become a viable prefix, right? So this particular statement is under that assumption that beta 2 is not nullable. Okay, so there are some homework exercises in 4.6.6 in ALSU's book. Those might be worth trying out, apart from the exercises that I have mentioned in the slide. So let's move on. So we said that we built LR0 automaton, and from there we had SLR1 parsing table. So after LR0 automaton, we looked at the symbol, the lookahead symbol, and built the automaton. LR1 parsing essentially encodes the lookahead in the automaton itself. So the lookahead was separate from LR0 automaton. That's why we had 0 in LR0. Now if I want to embed this lookahead as part of the automaton itself, I am expected to get more power. So let's see how that gets done, and once we do that, that is something which we can call as LR1 parsing or LR1 automaton. So let's take example of this thing which had this shift reduce conflict issue. Maybe we will change the grammar. You can try that out maybe later if that satisfies our LR1 automaton. Right? Because we said that the language is not ambiguous, so does LR1 automaton help us in identifying, in parsing this particular language? I'm going to change the language a little for our discussion. I'm going to use this language. So S prime derives S derives capital C, and capital C derives small c, capital C or D. The way I am going to construct the automaton, I0 is going to be S prime deriving dot S followed by a lookahead. Right? What is that lookahead? That is going to be what is something which I am expecting at the end of this S. Right? So in this case it is going to be dollar. So if dollar appears and I am at dot S, that is dollar is the lookahead that I am expecting after this whole production is done, then I know that I should take care of this. In LR0 we were not looking at the lookahead. So even if that dollar after a capital S, even if it would have been C or D, I would have still gone ahead into the transitions, into the go-to of from one state to another in the automaton. But in this case, as soon as C or D appears after S or likely to appear after S, I am not going to go ahead because that does not match with the current state. Right? So the lookahead must match the current state in the automaton. Right? So I am going to write that like this. So the initial state is going to be similar with respect to the first part, but the second part of lookahead is something which I am going to add now. So S prime deriving dot capital S with dollar as the lookahead is our first kernel item. From there, other non-kernel items are going to get added. There, I am going to say that S also derives dot CC, and that dollar is going to follow from this whatever we look at it for capital S, I mean capital after capital S. Now let's understand this a little carefully because that lookahead is changing now. From this first capital C, I am going to derive dot CC, right, with lookahead as not dollar, but the lookahead should be. So if I am talking about this first C, the lookahead should be the first of second capital C. If I am deriving a non-kernel item from the first C, this one is same as, this one is same as this C, because I am deriving it from that item, then the lookahead should be after this C gets reduced, that is dot C capital C gets reduced to capital C. This C is going to be the first C, and therefore the lookahead should be the first of this capital C, which is C or D. Right? The first of capital C is anyway going to be, there are only two terminals here, small c and small d. and those both are in the first of capital C. So those are the ones which are going to appear in the lookahead, right? If it would have, okay, and we'll move further so that we'll also know the other kind of situation that we might get into. As far as this second rule is concerned, that is also coming because of this C. So this particular C is also coming, this is the same C as this, and that can derive dot B with again the first of the second C as the lookahead. So that appears here. Right? Anybody who has confusion in understanding this? Anybody wants me to repeat it? Okay. Can some people quickly mention that whether you have understood it? Lookahead is little similar to follow. Yeah, lookahead, I mean, see, the lookahead is definitely, so whatever is the follow that we are expecting from the grammar, if the lookahead from the input is turning out to be the same as the follow, then we go ahead and match it or use it, or alternatively, if the lookahead does not match the follow, then we have to give it. Okay. So at least a couple of you seem to have understood it. Okay, let me go over it just quickly once. So we are saying that S prime derives dot S, this is your kernel item, with dollar as the lookahead. Right? So that part is okay. Now S derives dot CC here, with again dollar as the lookahead. Where is the dollar coming into picture? If dot CC reduces to S, then dollar should be the lookahead symbol. That is what we derive from the kernel item in the non-kernel item. Right? From the second item in this set, that was deriving .cc, I am going to now, let me call it as C1 and C2, right, just for the exposition purpose. So .c1, C2 is something which I have not derived. Now .c1 can, so since I have not seen .c1 can also, that means that I have not derived whatever is derivable from .c1, from C1. What is derivable from C1? That our grammar tells. .c, capital C, and .b are the ones which are derivable from C1. So I am going to say that C1 derives .c, capital C, and C1 derives .b. Right? So this part without the lookahead is same as what we have in the LR0 automaton. Now for the lookahead part, for last two corrections or last two items, what should appear? So if I reduce .c, capital C, or .b to this C1, what should follow is going to be the first of C2, this C2. And therefore, first of C2, which is essentially first of C, is going to be appearing on the lookahead for these two non-kernel items. It won't be dollar. Dollar is going to appear when there is a transition from this, let's say there is transition from this here on capital C. Right? After that, S deriving C dot C is going to appear with dollar as the lookahead. Right? And from that C1 dot C2, when we try to derive items dot C, C2 and dot B, at that time dollar will appear as the lookahead symbol, not in the first C1. Okay. If there is still confusion, please feel free to ask. We'll move ahead from here. Yeah, so I1 is essentially our accept state, I mean just from the accept state. On C, as I was mentioning, we have this S deriving C dot C, that is our kernel item. From here we are deriving dot CC and dot B with dollar as the lookahead, because this C is now C2 rather than C1, right? Because this C matches this C. Okay, and there are more such transitions which are going to be there. I request you to try out the other combinations with other transitions possible. So for example, from I0 there are transitions on small c and small d possible. Similarly, from I2 you can have transitions on capital C, small c and small d. Maybe someone can tell me the state from I0 on capital C. Capital C is done on small c. I0 small c. Anybody? I0 on small c? Okay. So I0 on small c, okay. C deriving C dot capital C dollar, okay. Will there be more non-kernel items into this? C deriving C dot C CD as the lookalike, C deriving dot CC with CD as the lookalike. Okay. Any other suggestions here? So we have two answers. Also, okay. So there is a third answer now. So there is change in the lookalike. So definitely what Venkata Surya had written. Okay. So let's do what discussing. So what Venkata Surya had written was the kernel item. However, that look ahead, and then when we do the non-kernel items, then we get what Arnav and Sarthak and Nishchit have mentioned. So this look ahead is the one which is differing across these. Definitely dollar will not be the look ahead because we are talking about small c, and if C derives C dot C, that is small c dot capital C, then the look ahead is going to follow. Therefore, CD is going to be the look ahead. So that first part, which is common in Arnav and Sarthak's suggestions, that part is correct. The second part, C deriving dot CC, is also correct, and C deriving dot D. The look aheads are changing. Let's understand what should it be. This capital C we are talking about is the capital C in the this capital C from the previous item, right? C deriving C dot capital C, right? So the non-kernel item is being derived from the C of the kernel item. The C of the kernel item, if you reduce it, what should be the look ahead? That should be coming from the kernel item itself rather than thinking about what the next input should be. Right? So Therefore, C or D is going to be the look ahead rather than the dollar, because that CD is going to be the look ahead for the kernel item. So in Arnav's or even Sarthak's thing, when we look at the kernel item, C deriving C dot capital C with look ahead as C slash D, when you are deriving from that capital C, the look ahead should follow. And therefore, I will just show you this. So therefore that CD should appear in the non-kernel items, which is the look ahead coming from here. Does that seem reasonable? Yeah. Okay. So let's complete the transition on small d from I0. So that should be simple. C deriving D dot with CD as the look ahead, right? And nothing else gets added. Okay. So now from I2 there are some transitions possible as well as from I3. I request you to try that out. Maybe I'll just quickly finish that up. So on capital C we go to, again, the dollar is going to appear as the look ahead. Here, when you have transition on small c and small d in I2, that is not going to change the look ahead, that is going to remain as dollar, so that continues to hold. And similarly on D, that dollar is going to hold. Right? So this, and then on I3 there are going to be some transitions possible. So on small c, small d, and on capital C, from I3 we are going to go to small c, capital C dot. We don't have any such state. As well as from I6 there will be some transitions possible. Right? So yeah, okay. On small c also there will be a transition from I6. So that will be, that is coming back to itself. On D it is going to go to I7. Yeah, okay. So this is probably going to be the end of it. And this is going to be LR1 automaton corresponding to this. And from here you can build again the parsing table by looking at the next symbol and so on. And we'll worry about that in our next class. Any quick questions?
Sir, I had a question in the starting of the
question. Let me bring out my headphone.
Sir, can you hear me?
Yeah, I'm able.
Hello?
Yeah, go ahead.
Oh, okay. Sir, I had a doubt in the starting of the class. Sir, in the we had got follow of s as dollar comma equal to, no, sir. But I think that equal to should not be there in follow of s.
It should not be there in the follow of s. Let me go back. Yeah, others can log out if they have other class. I'll just go. I think it's a little slow. Hopefully that slide is very okay. LibreOffice is not responding. Okay, I have probably stopped sharing the screen, but let me go back. So,
Okay.
so we said that follow of capital S
Is dollar equal?
and you are saying that equal to should not be there.
Yes, sir. Because like we had the production s gives L equal to R or R. So from this we'll get that follow of R should contain follow of S. But that should, I think it shouldn't mean follow of S should contain follow of R.
Mm, okay, follow of R should contain follow of S. That statement is correct. Whether follow
Yes,
of
sir.
S should contain follow of
No,
R.
should not. Follow phase should not contain follow phase.
Mhm. Okay, okay, let me see.
I mean, need not. Like from this production, we don't get that.
Hmm. I see. Right. Yeah, that seems reasonable. Anybody has any suggestions on this one? So our grammar was S deriving L equal to R or R, and therefore follow of R should contain follow of S. That is correct. Whether follow of S should contain follow of R, that yeah, it seems to me that it should be there, but I'm not able to correctly point out. Anybody wants to
Okay.
say anything on this? Okay, let me see. Pragyan says once we use the first production, we'll never come back to S. So follow of S cannot contain equal to. Hmm, I see. Okay, I think I'll have to think offline about this. I'll think and either post it or convey it in the next class. Okay,
Okay, sir.
Nishit.
Yes, sir. Thank you.
Any other concerns, questions? All right, so we'll stop here. See you in the next class. By the way, today we will have the lab at 2 o'clock. I may not join. If you have questions, you can come and ask questions either related to, mostly related to assignment because I may not be able to join. But I'll ask the TAs to be around. Or otherwise, if you want to post it on Moodle, that is also okay. All right, see you then.